In today's lecture, we will discuss the gray reflected binary code and we will see the steps involved in the development of the gray reflected binary code. Many binary codes which are useful in a variety of applications and digital systems have been devised. One of these codes is the gray reflected binary code, which is often used in digital systems. So let us see how to write the gray reflected binary code. For this, first we will write the first two numbers 0 and 1, and we will place a mirror below these two numbers and we will see the reflection of these two numbers in the mirror. The reflection comes out to be 1 and 0. Now we will add zeros before the digits 0 and 1, and below the mirror we will add ones before the digits 1 and 0. So now the numbers comes out to be 0 0 0 1 1 1 and 1 0. So this 0 0 represents the number 0 in decimal, 0 1 represents the number 1 in decimal number system, the number 1 1 represents the digit 2 in the decimal number system, and the digits 1 0 represents the number 3 in decimal number system. That is, the decimal number 0, 1, 2 and 3 are represented in the gray reflected binary code as 0 0, 0 1, 1 1 and 1 0 respectively. Now in order to obtain the next decimal numbers, we will consider all these four 2 digits numbers which we have written here, and again we have placed a mirror below these 2 digit 4 numbers, and we will see the reflection of these 4 numbers in the mirror, which comes out to be 1 0 1 1 0 1 and 0 0. Now what we are going to do, we are going to add zeros above the mirror, that is, before the digits 0 0 0 1 1 1 and 1 0 we will add zeros before them, and similarly the digits which are below the mirror we are going to add 1 before these numbers. So now these numbers becomes 3 digit numbers. So the binary digit 0 0 0 represents the decimal 0, 0 0 1 represents the decimal 1, 0 1 1 represents the decimal 2, 0 1 0 represents the decimal 3, similarly 1 1 0 represents the decimal number 4, 1 1 1 represents the decimal 5, 1 0 1 represents the decimal 6 and 1 0 0 represents the decimal 7. That is, these 3 digit numbers are the gray code representations for the decimal digits 0 1 2 3 4 5 6 and 7. Now in order to obtain the rest of the decimal numbers, we will take all these 3 digit 8 numbers and we will again place a mirror below them as shown in this figure C. So in figure C, we have taken all these 3 digit 8 numbers. We have again placed a mirror below them and we are seeing the reflection of these 8 3 digit numbers in the mirror, which comes out as shown in this figure. Now what we are going to do, we will add zeros to all the numbers which are below the mirror, and we will add 1 to all the numbers which are below the mirror. That is, we are adding zeros to all the numbers which are above the mirror, and we are adding ones to all the numbers which are below the mirror, so that now we get 16 numbers which are of 4 digits. So these numbers are representing the decimal 1 to 15. I hope it is clear. Similarly, if we want to write the decimal numbers after this, we are again going to take all these 16 numbers. Again, we will place a mirror below them, and we will see the reflection of these numbers in the mirror. Then again, we will add zeros to the numbers which are above the mirror, and we will add ones to the numbers which are below the mirror, and we'll get the decimal gray code representation for the corresponding decimal numbers. So this is the way in which we can find the gray reflected binary code for a given decimal number. Now, what is the use of the gray reflected binary code, which will be clear from the table which is shown here. Here we have shown the comparison between the binary numbers and the gray reflected binary code for a given decimal number. So if we represent the decimal 0 in binary in 4-bit form, then we can write the decimal 0 as 0000. In the gray reflected binary code also, we represent decimal 0 as 0000. Similarly, the decimal 1 is represented in binary as 0001, and in gray code also it is written as 0001. Now the difference comes in the decimal digit 2. 2 in binary is written as 0010, whereas in gray reflected it is written as 0011. Similarly, 3 in binary is written as 0011, and in gray reflected it is written as 0010. And similarly, the rest of the decimal numbers. Now, the most important advantage of the gray reflected binary code is that whenever we write a number in the gray reflected binary code, then the successive numbers differ from each other in only 1 digit, whereas if we write the numbers in the binary number representation, then the successive numbers may differ either in 1 bits or 2 bits or 3 bits. That is, there is no fixed pattern in case of binary numbers. But in case of gray reflected binary code, if we observe the successive numbers, we find that the successive numbers differ from the previous one in only 1 bit. So let us see how. Here we find that there is 0001. When we come from 0000 to 0001, we find that there is a change in only 1 bit. But if we move on from this to this, we find that this bit has changed and this bit has also changed. That is, when we move from decimal 1 to decimal 2 in binary number system, we find that 2 bits have changed. That is, this 1 is changed to 0 and this 0 has changed to 1. Similarly, if we move from 2 to 3, we find that only the last digit has changed. Similarly, if we move from 3 to 4, we find that there is a change in this bit, there is a change in this bit, there is a change in this bit also. But if we see the same thing in case of gray reflected binary code, we find that when we move on from the first number to the second number, there is a change in only 1 bit. Similarly, if we move from this digit to this number, we find that again there is a change in only 1 bit. Similarly, if we move from here to here, we find that again only the last bit has changed. Again, if we move from this 4-digit number to the next 4-digit number, we find that only the digit 0 has changed to 1. Similarly, if we move on from this number to this number, we find that only the last digit has changed. So in this way we will find that whenever we write a number in the gray reflected binary code, we find that if we move from one number to the next number, there's a change in only one bit, whereas in case of binary number system, there is no fixed pattern. When we move from one number to the next number, it may change. There may be a change in 1 bit or 2 bit or 3 bit or 4 bit and so on. So this property of gray reflected binary code, that is when we move from the one number to the next number, then there is a change in only 1 bit. This property is made use of in many applications in digital system. So this is why it is important to know about gray reflected binary code. I hope this is clear. So this is the binary number representation of the next number systems.